Hello folks, I'm here today to demonstrate how to use R within RStudio for the very first time. So if you are, you should have already, I would say, do the steps implied in this handout, Intro to the Virtual Desktop. We're at step 5A, so that's where I'm going to pick up. You can use R on the virtual desktop, but you don't have to. The whole point of using R is that you can download it for free and install it anywhere you'd like. So I'm going to use R as installed on my current laptop here. So when you open it for the first time, you will see a whole bunch of different windows. It can be kind of overwhelming. This is something you can customize as well, but we're going to start by opening the syntax file that goes with example 1. All right, so let's go into that. I'm looking for the .r file of these, so .r are syntax files. And here we go. So now I have a new window that, let's see if I can make it any bigger. I bet I can. Oh, I can make the whole thing bigger. Very interesting. Okay, that should be good enough. So the way mine is organized is that the code is up here, and what the code generates is going to be shown down here in the console. And to get rid of the stuff that you don't want to see, there's a little broom icon over here that clears it out. So, all right. So you'll note a lot of green code. In my R examples, these are comments. Comments are notes to yourself that the computer will skip over. They form a lot of useful features, not just for documentation, but also so that you can contain extra code that you may not need, but you don't want to delete. So I'll show you an example of that in just a second. So I have a label here as to what the syntax file is about. The first thing that I do in all different packages that I use is customize the output. So for instance, you can control how many digits across this prints. That way it doesn't wrap before you want it to. You can control the number of significant digits in some functions and not others, but this works for some of them. And you can also control when scientific notation kicks in. So this means I need 9 zeros before that happens. So I have a note here about colors within these systems. These are all things that you can change, but sort of like what happens by default. So this is RStudio. RStudio is a Windows interface that makes R easier to run. So we are using R software, but we're using RStudio to access it. So each R command is contained in parentheses. R is built almost exclusively out of functions. The other thing that's different about R is that because you can have multiple data sets open at the same time, all commands need to be specific as to which data set you're talking about. So comments are green, system commands, some of them are blue. Things that you would generally need to change, like variable names and file names, are in black. Labels and titles are also green. And any X argument down here is going to refer to the name of the data set and the variable to be used. So to execute code in R, you highlight whatever it is, and you can click the running icon, or you can click, the keyboard shortcut is Control-Enter. So if I want to do that, I'll go ahead and do this one, Control-Enter, and see it copied down here. So it copies down here what you asked it to do, but then I'm just controlling what the output looks like, so there's nothing else that needs to be seen. Now, one thing that's different about R than a lot of other packages is that base R, as it is known, like what you get like by default when you download R, has a lot of useful stuff, but then people invent packages that add specific commands and routines. And these vary quite a bit in quality and in documentation. But this example is going to use 2 for sure. And so one is called Read Excel, which reads in Excel data, and the other is called Psych. It was made by a psychologist to do basic descriptive functions. So in the syntax that I will give you for your homework, I will have commands like this that will install and load any packages that are needed for your assignment. So I'm going to go ahead and run that as well. Stop it. There we go. Okay, good deal. Next, you will see these kinds of comment blocks throughout my code to help organize it. Generally, it's like a section header to say what the code below it is going to do. So for instance, this one says data import and manipulation. One down here says univariate statistics. So this is the part that essentially you will get from me anytime you start an assignment, is a starter kit that helps you to do the steps of importing the data and labeling your variables. So set working directory, this is where your stuff is. Now, one thing that I mentioned in the other video that I want to reiterate here is that the slashes are backwards relative to what we would expect in standard Windows. So if I go into my example here and I hit copy, I'm going to put this down here so that you can see the difference, make it into a comment. That's what it looks like when I copy it out of Windows Explorer, but note the slashes then need to be turned back around in order to be used in this command of set working directory. So don't forget to do that step. Get rid of that for now. Okay. So the next step then, my comment says, is going to import the Excel dataset named GSS example. So that's where I'm going to use the read Excel function from this read Excel package. Back up, there we go. So what is happening is that I am telling it, hey, go to this place, because I set it the working directory here, find this file, and go to this specific sheet. So the things here in quotes are case and space sensitive. You got to get them exactly right. And then I am saving the data set in an R format to R's working memory, and I'm calling it example 1. So let me go ahead and do just this much. I'm going to run these commands. Oh, and I'm going to accidentally delete them because I did the status shortcut instead of the R one. That happens at least once a day. So note over here in this data section, I have example 1, and I can double click on it and see my data set. So you can sort, you can look, you can scroll, you can do whatever you'd like in here. I'm going to save my work in the syntax file here, so just in case. And you can also expand it, so it will tell you the names of your variables and what kind they are and the first couple values. This can be useful to refer to when you're typing your code to make sure you get the case and spelling right for things. And because I've had bad luck with different packages installing, or excuse me, loading data in different ways, they can load it as a data frame, as a table, something called a tibble. There's a few others I've come across. Perhaps superstitiously, I always do this command of making sure that it is a data frame because that is what is needed for most kinds of analyses that I've seen. So I'm going to go ahead and do that as well. Cool. Now in R, there is no direct way to label variables that all different functions will be happy with. I've discovered this the hard way as well. So my workaround is, rather than try to actually apply the variable labels to the variables in the visible data set, I just write them in here as comments. So these are the same labels that we saw if you watched the Stata video by chance, where they actually get attached to the columns. They're just going to be in here for your own reference. Likewise, there's no direct way to install value labels, and so here's a workaround. Essentially what we're going to do is create 2 labeling conventions. So these would be value label formats in other packages such as SAS or Stata. And so C with a parenthesis like that is a concatenate function. It means stick this stuff together like as a set, as one object. And this is going to be the labeling convention that applies to my marital status variable. This one, happy labels, is going to be a labeling convention that applies to my 5-category ordinal happiness variable. So I'm going to run these 2 things so that you can see what happens when we do that. There we go. They show up over here. So what I'm looking at over here is what's labeled the global environment. And this can be data sets, this can be functions, these can be labeling conventions, these can be objects of various kinds. So it gets to be a little confusing sometimes to figure out how to access them, but these are basically all the things that R is hanging on to in its stored memory currently. And now what I'm going to do down here is a workaround essentially for value labels, in which I take these values and I apply them in order to each possible unique value that's in this. So basically it's going to be like the first thing I see is 1, okay, I'm going to stick this on there. Do it for all the 1s. Then if I find a 2, I'm going to stick it on here. So it's in order, it's not necessarily the same values, but this then is creating, so example 1 is going to be the name of the data set. Then we have a $sign as a separator, and now I'm going to be creating a new variable that is named that. And it is being created as using this labeling convention as applied to the name of the old variable. So marital is what it is called in the data set. There it is. And when I run this, I will be adding columns for the labeled versions of marital and happy. So let me do that real quick. And you can see down here what has happened. So it didn't just go in order of 1, 2, 3, 1, 2, 3. It actually tried to follow what the values were. So we're not changing the values, we're just labeling them, which is a nice feature. Okay, let's make some output. So we're going to generate some univariate descriptive statistics. So if I have a categorical variable, so something that is binary, nominal, or ordinal, I'm going to use marital status here, the labeled version, to demonstrate. There is a command called table. So when you see my syntax examples, there will usually be comments that either describe what is happening, what it's used for, where it came from, or what any specific options do. So for instance, there's this use NA equals if any option. I have a note here that that means to include missing values. Then you will usually see a print command that is a label that will then show up on your output. So it shows up in the saved output for sure. In the console, everything shows up. So I use print to make sure that it makes it into the external files to save your work that I will show you how to make in just a second. Now you don't have to do this step, but I highly encourage you to do things like this to make your output easier for you to read in the future and to make it crystal clear what a given command is being used for. So I'm going to do these two right here and run those. And here we are. So I have the command repeated back to me, as well as the label that I created. And then here are the frequencies of each of the marital status categories. So this was in lecture 1. This is how I got this stuff. Now, if I want to get the proportions out of the total instead, I can do that here with a print command labeling these as proportions, and note a nested function structure here. So table right here, this much. That is literally the same thing as what's up here. So that part is just getting the frequency table again. So X means what do you want the frequencies of? And I want it in example 1 data specifically. I want this column specifically. I want you to include missing values. And so then what prop table is doing, it's going to convert these frequencies into proportions by dividing by total. So I will run those two commands to show you what that output looks like, and there it is. So this output gets kind of cluttered. I tend to sweep it fairly frequently so that whatever I care about is more obvious to me. If you want to make a picture, we can do that. There's a command in base R called bar plot, and it wants to know what you want to plot. So the answer is I would like the height for this to reflect the frequency. So this is the table command of this variable. So again, this piece is the same thing as we had up here. I would like the label of the y-axis to say frequency, the label of the x-axis to say marital status, and let's see what goes. So I can either include the comments or not. If I include them, they're printed down below, but not if I don't. So actually, let's go ahead and do that. Ta-da! Look over here. I have this nice little picture. So these will show up over here, and they can look kind of funny. If you have a very squishy thing, they'll change the picture, as you can see. So you might want to make sure that you have enough space so that you can visualize what you had intended. Here is how to trick it into plotting percentages. We're going to do the same thing where we wrap the table command inside this prop table so that we're able to do that. And then I just manually turn these into percentages by going times 100. So I'm sure there are other ways to do it, but this is the way that I found that worked. So I'll go ahead and run that. So now you can see that the scale of the y-axis is percent rather than frequency. And if you wanted to save this little picture, you will need to do so. Here's a way to write code to do it. So there's 3 steps to this. One is to open a file and give it a name. The second is to tell it what you want in the file. So this is the same command as above. And the third is to close the file. So running these steps is how I got these plots in here. So it knows where to go to save these plots to based on wherever your current working directory is. So the command that had that definition was one of the first things up here. So it's going to go to this place when it saves things that are requested. So I made 3 different plots in R, and I had made plots in Stata that were saved to this folder as well. Okay, moving right along then. So that's how you would generate a plot and save it. And here's one more showing the ordinal happiness variable. I'll just run the plot part of that so that you can see that. And so this is the percent of people who answered each level of happiness, where I need to expand this to be able to see all the labels. So there we go. Cool. So this isn't so bad, right? In summary, you would use the, let's see here, you would use the table command or prop table for categorical variables to see the frequencies of each category. But for quantitative variables, that's not going to be as useful. So to demonstrate why, I'll generate the same type of output for a quantitative variable income, in which you have a list of how many people were in each of these specific values, and the values themselves are plotted on the x-axis, but in such a way where it doesn't pay attention to the interval between. So this is not a very useful plot. We will make a more useful one in just a second. So to do summaries of quantitative variables, numeric variables, there are many ways to do that. I'm going to use a package called psych that has a function called describe that's pretty easy to work with. So I am going to make a title for this for my own edification. And then inside this print function is that. So right here, I'm asking, what do you want to do with respect to describing things? And then print means I would like 4 digits after the decimal. So I'm going to describe dataset example 1. The variable is called income. I'm asking for it to give me 3 quantiles as well as the interquartile range. And then the print aspect of it out here is asking for 4 significant digits. So let's see, actually let's clear this thingy and then let's see what we get. There we are. So it's not labeled super well, but it's good enough. You can see that we have 734 people. We can see the mean, standard deviation, etc. Note that this list of statistics does not include variance. If you want to get that, a simple way to do so is just a little function var that stands for variance. So I will run that little function along with this comment. And so you can see it returns the variance of 190. So that is this number right here. Actually, nope. This one, standard deviation, squared. So rather than getting your calculator out and squaring it manually, you can ask Stata to do it for you, or R to do it for you instead. But this also can be used as a calculator. So for instance, if I didn't know how to get the variance and I just was like, I need to figure this out, I could do this. And then it would print the result. So R will do math for you. Now note what this is happening. Look at what just happened. I'm using Copilot with R, and it guessed what I was trying to do, and it wrote a comment. So I'm going to hit Tab to actually lock it down. So this is super useful once you get going and you just want to save yourself some typing. Copilot will infer from your labeling system what you would want to do. So note, even like I have a practice of always putting a space after the start of a comment, and it did that for me. So pretty cool, I must say. Likewise, if you ever just wanted to get a mean for a variable as a piece of information or a standard deviation, here's how you would use functions similarly. Note the semicolon in between is a way that you can have 2 requests on one line, otherwise that's not allowed. So I can run that and see these 2 numbers down here. So they're not labeled very well. You have to kind of keep track based on what you're ordered, but you can probably figure it out. So then we can make a histogram to see the distribution of income as a quantitative variable where it's essentially creating bins. So you can tell it how many, you can tell it what to label things. And again, X refers to what we are making a histogram of. So I'm going to do that. And now I have a new picture over here that has that positively skewed distribution that we've seen in several slides. So if I wanted to save a plot then that's like this, I would have the same process of creating a file and opening it, telling it what I want to go in the file, and then shutting the file. And so that's how these plots in here were made. All right, last but not least, this console gets cleared a lot, gets a little ugly. It's very clunky. There are many ways to make nicely printed output out of R, including markdown files and other kinds of documents. I'm going to show you something real bare bones that I find useful, and I do all of my teaching documentation this way. So I found a package called Teaching Demos that does what you would expect, so I'm going to load that package. So this is an example of how to use that package. One of the commands is text start. So I am then essentially saying, hey, open a text file with this name in the same place that I named for my working directory above. So I'm going to run that. Then you would insert whatever code you want to be included in that output file. So for instance, if I want to have a table of marital frequency, here it is. And if I want to have a table of proportions instead, here it is. And so now I can do text stop to close the file, and whatever I just asked for will be inside that text folder. So this is what it looks like. And you'll note that inside this text folder, everything is printed right on top of each other without spaces. And so in my example files, you will see, let me open one recently, grab something from, all right, so here's something from my other class. This has a lot of code in it, but what you will see between models is this in my examples. That is literally to insert a blank space in the output so that the output file has at least breaks to it. So you don't need to include these ever unless you're generating an output file and you care about having the breaks in between. So no worries on that. All right, I think that's everything I wanted to show you for today. Oh, no, it's not. I just remembered one more thing. What is the process for doing homework like? Well, here's what I would want you to do. Start a brand new syntax file, an R script right here, a blank one. You would log into the homework system. So for instance, for homework 1, I've logged in here, and you would download the R starter syntax file. So here it's opening up in a separate window. I'm going to copy all of that and paste it into my new open window here. And I will move this down so that we can see it a little bit better. So this is the type of file I will create for you when I give you a new homework assignment, and I will have all of the packages in it that the homework assignment will require, so you don't have to guess what is needed. And then I have an example of how you would import your data. So you would change, for instance, this path to wherever your data are. Then for the name of the data set, you would change this number to whatever your 8-digit ID is. And then the rest of this is me adding labels for things so that you know what the variables mean, as well as value labels so you know what the specific values mean. So then down here, I have the text start commented out so in case you don't want to save your output. If you do, then just turn it on by changing it from a comment into a command. And it says your code goes here. So for instance, if I have a variable in homework 1 for age, and I want you to find the mean age. Okay, so the process would be go over to example 1 here, since that's the corresponding example for this assignment. Age is a quantitative variable, so I need to find an example of how to make a summary of a quantitative variable. Oh, here's one, just like for income. So I'm going to copy that example of how to make a summary of a quantitative variable, and I'm going to put it over here. So since I'm not going to use income, I'm going to change that to age in here. And this data set is what the example one is called. Mine would be called homework 01, for instance. And the column that I am asking for is H. Pretty much everything else could be used. So again, the process is to find the corresponding example of what I'm asking you to do, copy it over into your syntax starter file that is customized for your assignment, and then figure out what aspects of the code need to be changed to work for your purpose. And find and replace can be your friend, okay? So for instance, there is the word example 1 in a whole lot of places throughout this file because that's the name of the data set. If I wanted to change it in one fell swoop, what I could do is go up here, Control F is find. Like I could say find all instances of example 1 and replace it with homework 1. Since I know that's going to be the name of the data set, right? So then I solve that problem. If I have to do something for an outcome variable where I have multiple models, I can change the name of that in one fell swoop. So find and replace can be your friend. And make sure that you are saving your work. So this is the syntax file that you would be generating for your homework using the corresponding example file as a template. So save them both and keep them separate. All right, I think now that is everything I wanted to say. So thanks for listening. I hope this helps, and I hope to see everybody soon.